Now we are going to discuss about KNN algorithm and how to implement the KNN algorithm. So this KNN algorithm is a nearest neighbor algorithm which is actually used in the entire data set in its training phase. Whenever a prediction is required for an unseen data, we are just going to apply the K most similar instance or else this K algorithm. This K nearest algorithm is used in a classification algorithm which is going to operate a very simple principle. So for example, now we are having the similar image. Now we are going to find multiple items. So for example, you have something like 1, 1, 1, 1 and you want to find the 2 which is actually similar to 1. Now we are just going to find the item which is similar to 1 from the actual data set. So this is what our KNN algorithm is. So now we having one more example. We had a data of dogs and horses with a height and weights. So now we need to identify when you are getting the new point, you need to get to know this point is belong to horse or dog. So now this algorithm suggests that if you are similar to your neighbor, then you are one of them. For example, if apple looks more similar to peach, pear and cherry, then monkey, cat or rat, then most likely apple is a fruit. So when we are just going ahead with KNN algorithm, we need to follow some steps. So first we need to know how does KNN algorithm works. This K nearest algorithm uses a very simple approach to perform a classification. When tested with a new example, it looks through the training data and finds the K training examples that are very closest to the new example. So now we are just going to assign the most common class label among those K training example to the test example. So where we are having a data like this. So now this is the new point. So now we just chosen one K value, that is nothing but as K equal to 3. Now we have a class A and a class B. Now I want to know the star which is belongs to class A or class B. So this KNN algorithm represents the number of nearest neighbor points which are voting for the new test data. So here we have a class 3 test example or given the same label. So now based on this class 3, now we need to know this red color star symbol is belongs to this class B or class A. And when we are having the class 6, now we need to get 3 more closest classes. Now we need to make this label, this red color is belongs to class A or class B. So now we need to know about this point is belong to which category. So to get to know about this, we are applying our KNN algorithm. So these are some simple advantages. So it's very simple and it works with any number of class. It's easy to add more data and we can able to handle some parameters like K, distance matrix like that. So now we need to know about the implementation. Suppose we have a height and weight and its corresponding t-shirt size of several customers. Your task is to predict the t-shirt size of one person whose height is 161 centimeter and 61 kg. So now how you will do this? So this is what your previous data set, your heights and your weights and your t-shirt size. So now we need to predict the test size, new customer t-shirt size. The customer is 161 in a height and 61 in weight. So now we are going to calculate the Euclidean distance between the new point and the existing point. For example, the Euclidean distance we are just getting P1, that's nothing but 1, 1 and P2, that is nothing but a 5, 4. So this Euclidean distance we need to calculate like this: 5 minus 1 the whole squared and 4 minus 1 the whole square, that's nothing but this and this, P2 minus P1 the whole square and P2 minus P1 the whole square. So now this is the point which we get in. So the next step is, here we calculate the Euclidean distance between the point 1 and between the point 2. So now the same step we are going to apply to our actual data set. Let's see how to apply that. So in your first step we are having 158 and 58. So now we choose the value of k and select k neighbors closest to the new point. So in this case we are just going to select top 5 parameters having at least Euclidean distance. So now we are just calculating the Euclidean distance for our height and weight. So by using this formula. So 161, that's nothing but our actual point minus A2, and 61, that's nothing but actual weight of the person, and minus our B. So these whole square root. So now we are just getting the Euclidean distance. So now the step 2, that's what we now did. So in this case we need to choose the k value and we need to select k neighbor closest to the new point. So in this case we are going to select the top 5 parameters having at least similar Euclidean distance. That's nothing but a least Euclidean distance. So now this all the things which we are having. So the Euclidean distance which is similar between the datas like A and B, we are having a 5. So now we choose an 5k. You can choose 4k, 2k, 3k, it's all up to us. So now increasing the k value which will give the more accurate result. So now we just chosen the 5k5. So now the least Euclidean distance. So we have 1, then 2.2, and then again 2.2, and then 2, 3.1. I hope apart from everything is more than that. 11, 9, 9, 8, 7, 7, 5, 4, 4, 3.6 here we are having, and 3.6 and 3.6, 4.2. So I think we just choose we decided to choose k value as 5. Now this Python or Excel or R programming, whatever itself, this algorithm will choose the least value in the Euclidean distance, the 5 parameters. So this is the least 5 parameters. So now we are making this in the arrangement. So this 1.4 becomes 1 and 2.2, 2 becomes 2 and 2.2, 3, 6, 0, 6, 7, 9, 7, 7. It's almost same. So anyhow it comes as a 3, 4 or a 3, 4, whatever itself, because it's all same. And then 3.1 we are just making as a 5. So now we find the nearest neighbor. So we are just look for the top 5 values. We just make it in our ascending order. So our step 3 is we need to count the k neighbors by predicting the value. Since our k value is 5, we have a 4 t-shirt size of M. Therefore, according to the KNN, height of 161 and 61 kg may be M. So how I am telling you is, see, like here we have the 5 data. So this. So the majority Euclidean distance, which is nothing but our M data set. Yeah. So now we need to find the nearest neighbor. So looking at the top 5 values in ascending order, we just have 4M. That's nothing but 4M. So our t-shirt size for the height 161 centimeter and weight 61 kg is fit to M data. Yeah, M size t-shirt. So now this is what we analyze now. So now this are the steps we need to handle before you are implementing your KNN. We need to handle the data, then we need to calculate the distance, then we need to find the nearest, then we need to predict the class, then we need to check the accuracy. So the next step is we need to apply this KNN with our Python.